Hi, congratulations. You have made it to the end of the course. We have our consolidation session, which will come out in two parts. It is quite big, and it's important that we do take rests when we're doing this. So if you need to rest earlier than the break, obviously, please do. You don't have to treat it as a test. If you want to look anything up, you can. I think we kind of know the process by now. So this is it. This is our last bit of work together. So the first question's there. Pause and hit play when you're ready. All right, so I'm just looking at the end. Circles over -2. Don't want that. That's a bit big. There, that's better. -2. And it's over the 3. P has been given to us, so I'm going to use P. It doesn't equal the 3, but it can equal the -2. Now, if you missed that, which is very easy to do, and you put an X in there, don't panic. I haven't to date ever seen someone lose a mark because they used the wrong letter there. They're really testing about the symbols and your endpoints. So do not worry or think that you are wrong if you put a different letter in. Okay, next question. Now, one of the things that I want you to be doing all the way through this is to be, when you're stuck, I really want you to practice that. What am I looking at? You know, what are the key words? What's in the diagram? You know, what do I know about these things? You know, when you hit a brick wall, it's like you do it again. You go, okay, right, now I'm stuck again. So what am I looking at? How can this help me with my new problem or whatever it might be? All the way through your exam paper, all the way through this consolidation, you should be going through that loop of what am I looking at? What do I know? How do I use it? Let me try something. All right, I'm stuck. What do I do? Etc. etc. Okay, so hit pause, press play when you're ready with this one. Okay, so keyword, volume. Okay, I can see the triangular prism. I can see numbers. I know what volume is. Volume is the area of the front face times by the third length. So I know what I'm doing. The area of the front face, when I look at that, I can clearly see we've got a triangle. So base times height divided by 2 times by the third length is more accurately the volume. And straight away, I can see a problem because I don't have that base. So the very first thing that I need to get, I go to the diagram and it's not there. So this has turned into a harder question. This is what I'm talking about with loops. So now I've got to think, right, what do I know about right angled triangles when they've got a missing edge? And Pythagoras is going to come to the rescue. So we've got a squared plus b squared equals c squared. The two edges that the right angle point to, remember, are these here. Again, you go and get the information from the diagram. So I don't have the base. I've got 7 on that edge and 8.2 on that edge. Start doing some of the maths now, putting it in the calculator. So we've got our 49, and then the calculator gives us 67.24. And now work on getting that letter on its own. So a squared is now equal to 18.24 square root, and a is equal to 4.2708. And remember, don't round. That is our base. That's got to now go in here. And I can do that straight away. I leave that on my calculator screen, and then I can literally do that whole number, press times by 7, divide by 2, times through by the 16, and you will get an answer of 239.166. On and on it goes to give you a final answer, because remember, you always check to see what they want. They want 3 significant figures. So 200, I write 3 and say 2. 239, remember your units, centimeters cubed, and you're done. All right, so well done if you got that right. Next question. Describe the transformation. Hit pause, press play when you're ready. Okay, so I am going to write that it's a translation. That's important. There are 4 transformations. We've done 2 in this course, which was translation, which we're doing now, and enlargement. And we're doing it in a vector. That tells us what to do. So I'm going to use this corner here. 1, 2, 3, 4, 5 back. So -5. 1, 2, 3, 4, 5 up. So +5. Get those brackets in and job done. Okay, your next question. Hit pause, press play when you're ready. Okay, so we're going to tidy up the numerator. So it's a times question. We add the powers. A plus and a minus makes a minus. So we just end up doing 8 take 3, which is 5. And then we can apply our subtraction rule. So we end up with 5 to the power of 2. It is asking us to work out the value. So don't stop there. Work it out. And you've got 25 as your answer. Okay, next question is here. So just take your time with this. Is a big question. This is definitely, you know, something that's getting into those grade 5s that we've been preparing ourselves for during this course anyway. So you've got all the knowledge, but it's a big question. There are a lot of steps. So if you think, oh gosh, I'm going wrong, just keep going. You just don't know sometimes whether what you're doing is the right thing, do you? So rather than doubt yourself and stop, just keep going and say, right, I'm going to keep going with this idea, and then I might try something else. Never scribble. This is a really important thing as well. Never scribble anything out in your exam. You know, sometimes when you're like, oh no, that's wrong. As soon as you scribble out, you're telling that examiner, don't look at this. But if there was something really good under there and you just hadn't realized, he's not going to look at it. So never scribble out. Right, go. Have a go at that question. Okay, so we've got a cube and a cuboid, and we're being told that the surface area of each of those shapes is actually equal. And Sally's saying that the volume is 2. She's possibly making an assumption, or she could be right, but we need to prove it either way. Well, before we can get to the volume, we're going to need to know the edge of this cube. I can't tell the volume of that. I can't even tell the surface area of it, to be honest, until I get some numbers here. And as this is all I've got to go on, this is what I'm going to do to get us started. So the surface area is the thing that links these two because they're equal. So the surface area is actually what I'm going to do first. So let's take a look at this. The surface area of the front of this shape, okay, is going to be, so the front is going to be 4 times 6, which is 24. But then I'm going to double that because obviously the back is identical to the front. So that will give me a total of 48 for that one. I'll do this side next. Okay, so I've got the side that I'm working on now. That is 4 times 25, which is 100. And I'm going to double that because obviously the other side's the same. And might as well colour in the top, even though it's the only one left. There it is. I'm going to do the top now, which is 6 times 25. That's 150, which I will double because I've got that bottom as well. So I've got 300. And then that adds up to 548. All right. So I've got the surface area of my cuboid, and I know that that exact same number is the surface area for my cube. So I've got to think about how I would find the surface area. I know it's going to equal 548, but what would have been the steps had I had a number? Well, I know that all the edges are equal. So I have no numbers. I'm going to label that edge X. Which means that that edge is X also. And if I wanted to find the area of that shape, so the area of that shape, it's just going to be X times X. X times X, I can write that as X squared. I can't do anything more than that because I don't have an actual number, do I? Now think about the faces that we've got on a cuboid. If the edges are the same, then every one of those squares is the same. There are 6 faces and each one of those faces is identical. So I know that to get the area of 1, I need to do x squared times whatever that is by 6. And then I've got the total surface area, which I know the answer to. I know that that equals 548. All right. Now I have enough to help me find x, because actually that's just an equation. If I get it on its own, it will help me. So I'm going to divide that through by 6, which will give me x squared equaling 91.33, on and on, it's recurring. And then I'll I'll square root that, which will give me x is equal to 9.55, and on that goes. So this is great. It means that I actually do have a value now. It's 9.55 and on it goes. And remember, we shouldn't be rounding halfway through. So we've got this horrible looking number that we have to work with now. So let's just stay with the cuboid because we've got that number sitting on the display and we can start thinking about the volume. We know how to find volume. It's the area of the front face. Okay, so it's going to be x times x times by the third length, but all the lengths are equal, so it's times by x again. Now I know that x is 9.55 and on it goes, and I want to times that by itself 3 times. So I'm not going to try and type that in. I'm just going to put it to the power 3 because I've got 3 lots to do, and then the calculator is going to give me the result for that. Okay, so let's just put that in quickly now. So, and then we need to press that. And we've got an answer of 872.85 and on it goes. So I now know exactly what the volume of the cube is. I'm going to go back now to the volume of the cuboid because I need to compare and see if they're the same. So the volume of our cuboid is the area of the front face, which is a rectangle, 4 times 6, times by the third length, which is 25. When I put that into my calculator, I get 600. They are not even close to the same, are they? So the answer to that is no. Always make sure you do answer the question. So it's huge. You may actually want to, at some point, just watch that through again and see all those steps. If you got all the way to the end and you got that right, then just wow. It's a grade 5 question. There's lots of techniques and knowledge wrapped up into this question. I include things like this, not because I really want to make you feel uncomfortable, but I think it's just really, really good to be exposed to things when they're a bit different, because then they're not so scary when we see them the next time. So really, really well done. Wherever you got with that, I hope you were able to get some ticks in certain places if it didn't go as well as you would have liked. But yeah, it's a big one, that one. All right, so that's your next question. Hit pause and press play when you're ready. Okay, so for this question, I am looking at a trapezium. Barry wants to cover 20% of his garden in wildflower seed. Wildflower seeds are sold in packs that cover 2 meters squared at a cost of £4.95 each. And we're going to work out how much it's going to cost to actually do this. So we need to find out what 20% of the area of that garden is. So we need the area before we can find the 20%. So I could, if I wanted to, I could split this one. It kind of lends itself to doing the area of the rectangle and the area of a triangle. However, we've done lots of work with the trapezium. We should be able to spot that and feel fairly confident. So A plus B is 12 plus 18. I need to times that through by the height and divide it by 2. Put that in and I get 120 out. So that's the area of the garden, 120 meters squared. Now we want 20% of that. So 20%, 20 out of 100 times by 120, and you've got your 24 meters squared. That's the area that he wants to put wildflower seed over. Now the seeds are sold in packs of 2. So we're going to take our total 24, divide it by 2, and we are going to have to buy 12 packs. So 12 packs at £4.95 each is going to give me a grand total of £59.40. So quite expensive there. Hopefully the flowers will be gorgeous. All right, so that's question 6 done. Here's question 7. Hit pause and press play when you're ready. Okay, probably nice to have one that isn't all words, isn't it? Makes a change. That's the trouble with the grade 4 and grade 5 questions. They can be so wordy. So this one, anything raised to the 0 is 1. For this one, I've got that negative power, so I know it's a small number. I know it's going to be 1 over 4 cubed, and 1 over 4 cubed is 4 times 4 times 4, which is 64. Okay. And there's your next question. Hit pause and press play when you're ready. Okay, so we're being told that they're mathematically similar, which means all the edges should multiply up in the same way, just like an enlargement does. So if we take a little look at the small rectangle, and I'm just going to re-sketch it away from the diagram, I can see that it's 12 by 8. That's really simple. The larger one, okay, which I'm going to sketch here, we've got 12 plus an additional 4 for that but there, and then this is mirroring it. So although it's not labeled, and it may be that the question could have had that detail in a bit clearer, but because that is the same, you've got 8 getting added to the 12, so you've got 20 on that bigger one, and then the same thing's happening here. We've got the 4 and the 4 working both ways. This is probably my bad. I probably should have put the extra labeling in. You wouldn't have any confusion in a GCSE question because they make every detail really, really clear. All right, so you have got the 8 and you've got 2 4s, which is another 8, so you've got 16. And that's quite nice because 8 to 16 is really easy to see. That is going to be times by 2, and then it's actually really easy to see that that is not. 12 times 2 is 24. So are they mathematically similar? No, is the simple answer to that. No. If you had to explain your reason, then you would just go on and say that 20 would need to be 24 or something along those lines. Okay. Look at that. So that was a shape that was in a GCSE question. So we're using the same shape, slightly different question, of course. But that was it. Work out the volume of the prism. So I want you to hit pause and press play when you are ready. Okay, so when I first look at this, obviously they're telling me volume. So I should be thinking area of that front face times by the third length. Okay, so when I look at that front face, I can see it's made up of 3 shapes. So it's kind of feels quite natural to go and work on those. So we're going to start off by doing this rectangle here. I can see that this rectangle is 2 along and 10 up. So we've got 10 times 2, which is 20. And then this rectangle is a repeat. I've got 2 and 10 again, so I know that's 20. And then I start to focus on this middle section and what numbers I have available to me. So I can see that this edge here is 3. I can see the shape is a parallelogram. This here, I need to know. And I don't have that particular information, okay? And even if I went to the lengths of using Pythagoras to find it, which I could do, once I've got that, a parallelogram is base times height. This isn't the height of the parallelogram, it's a slanted edge. So even at this stage, it would break down. I am not able to find that middle section with the information that I've got in this question. So my initial thought process on how to solve this question is just broken down on me. And I think it's really, really important for you to be aware that this is normal. This is maths. This is what we do. We think of an idea, we try it, and we could hit a complete and utter dead end. So this idea isn't going to work. I'm going to have to think again. So I'm going to clean this off just so we've got a nice, clean looking question again. And I'm going to approach it in a different way altogether. Instead of looking at all those little sections, I am going to look at this like the front face is one big, giant rectangle. Okay. So I've got a height of 10, and I've got a base here of 2 plus 4 plus 2, which is 8. So the area of that square or rectangle is what it actually is 10 times 8, which is 80. But obviously that's too big because it's included two sections, a section here and another one here that isn't actually part of the front face. So if I can work out those areas and take it off, it's going to do the job for me. So let's concentrate now on the triangle. This distance from here to here is going to be 7 because that 3 and this 7 would add to make the 10. So I know the height of my triangle is 7. I know the base is 4. So the area of my triangle, which is base times height divided by 2, is going to be 4 times 7 divided by 2. 4 7s are 28. Half the 28 is 14. But of course, I have that other triangle as well. Just double check it's got the same dimensions. 7 and 4, it absolutely does. So that triangle will be 14 as well. So the area of my front face is the 80. Take away the two triangles, which is a total of 28. Okay. That gives me 52. So the area of my front face is 52. Now I'm going to times through by that third length. So I'll go back to my diagram, find the third length. That's how far back it goes there, which is 2. And I get a final answer of 104 centimeters cubed. So not too bad, but not easy either. Volume's just such a big topic, and they can give you all sorts of different types of questions to try and work through. So this is just an example of one that's different, where you feel like, oh, I've never seen that before, but it's a case of breaking it down. I've said it lots. What am I looking at? What do I know? And if you hit a brick wall, you just got to repeat that whole cycle. Okay, what am I looking at? How can I look at this differently? What else can I pick out? Okay. If you got that right, honestly, really, really well done, because it's not easy. It really isn't. All right, our next question is a translation. So have a go at that and press play when you're ready. Okay, so this is going to have a movement of 4 forward and 2 up, which is going to put it there. Okay, on to the next question. So read it through carefully. and then play when you're ready. Okay, so these sort of questions are getting more and more common when they talk about one shape and then try and link it to another. We just saw it obviously with that volume question. Now we're seeing it again here. So it's saying a square has the same perimeter as this trapezium. You've got to work out the area of this square. You can't even see it, can you? So one of the first things that I would really encourage you to do would be to add it to the problem, okay? You've got a square and you don't know anything about it. You don't know its edges. You just know it has the same perimeter, okay? So perimeter is the key word. To find the perimeter of a shape, we add all the edges. So for our trapezium, we would do 10 plus 9 plus 8 plus, and then we hit our problem. That edge hasn't been given to us, so we need to be able to find it. What we have got with trapezium is triangles embedded within them. So I would be able to just drop this down to make the right angle. This edge would be 9 and this edge would be 2. And then I can use my Pythagoras to find this one. So I've got a squared plus b squared equals c squared. My right angle is pointing to those two. So I'm feeding that information in, 9 squared plus 2 squared. So you've got 81 plus 4, which is 85. And then we're going to obviously root that in order to get our missing side. So our missing side is 9.2195 and on and on and on it goes. I'll add that in and I get a perimeter for the trapezium of 36.21 and on it goes. And remember, we've got to do our best not to be rounding as we go. So what I now know is that the perimeter of both shapes is this value. So when I go back over and take a little look at my square, obviously I know, and this is, you know, when I say, you know, what am I looking at? What do I know? That's this process. So I'm looking at, what do I know? I know all the edges are equal. So 4 times whatever one of these is going to help me find the edge. And I need the edge because the actual question is to find the area of the square. So I need an edge. I can't just stop. So I'm going to take that perimeter and I'm going to divide by 4 because I've got 4 edges making up the square. And that is going to give me 9.0548 and on it goes. So that is what one of my edges is. Didn't sound like very good English. And obviously the edges are equal, which means this would be as well. So I've got to times those two together to find the area, or I can just raise it to the power 2 and just square it, which is what we're doing. Okay, so once you've squared that, you would get 81.9909 on and on it goes. Check what they want, 3 sig fig. So 1, 2, 3, putting the cut there. Okay, 9 is big enough for us to be adding 1. When I add 1 to 9, I obviously get 10. So put down the 0, carry the 1, and you end up with 82.0. And it's really important that you keep that 0. I know it doesn't have any value, but they've said 3 significant figures, so I need 3 digits in that answer. Okay, so it's area, it's centimeters squared. So again, any part of that you got right, brilliant. These are big questions, but you can see how they, even though they're varied, they do rely on some of a kind of similar theme, if you like, running through them. Okay, I think we should do, maybe one more and then take the break, or should we do 2? Well, let's do that one. Press play when you're ready. Okay, so for this first one, we're working out x. It's a times question, so you add the powers. 4 plus something is equal to 9. So our x has to be 5. And then here it's the same thing. A power to a power is a multiplication. So 3 times y, a number I don't know, should be giving me 6. So y is equal to 2. All right. And I think we will leave it there. All right. We've had some really big questions. So take a break, pick it up when you're ready. That might be later today. It might be tomorrow or another day. And then we will finish it all off. All right. Well done. So far, so good, hopefully.